Thank you everyone for joining me. As today I'm going to be talking about how you can create fully reactive solutions using a new database specification called R2DBC. But first things first, it's probably best to, Elena gave an introduction to myself, but to kind of, if you can't see me on camera, this is the truest picture of myself as really the world's okayest programmer. In some instances, sometimes the worst, I guess, just depends on the code and depends on the day. But my name is Rob Hedgpeth, and I, as Elena said, I work for the developer relations team at MariaDB. And basically that just means that I spend my days doing anything and everything I can to help developers make their lives as easy as possible when using MariaDB products and functionality. If after this session, you'd like to reach out to me, you've got some more questions, maybe you didn't get answered during the session itself, please email me at robh@mariadb.com. You can follow me on Twitter at probablyrealrob, or I am going to be doing some live coding today. So if you really want to get out and judge the rest of my code, feel free to follow me and hit me up on GitHub at R2DBC. So let's go ahead and dive directly into it. And as I mentioned, I'm going to be talking about reactive programming with databases. And more specifically, I put here relational databases. And that's because if you're familiar with anything in the NoSQL or non-relational world, you'll know that a lot of NoSQL databases came with reactive approaches or using the reactive paradigm right out of the box. And this is something that the relational world really had to adapt to and kind of come up with an answer for, because as we'll see, it can be critical during the the development of your applications based on what you're trying to do. But before we dive into reactive development and specifically looking at the new specification of R2DBC, we really need to get a refresher for what reactive programming is. Now, and a lot of times in conferences, sessions like these, it's difficult to know where everybody is coming from. So what I like to do is kind of get everybody running at the same pace or on the same page so that when we get into the specification itself, we all have a pretty clear understanding of what the expectation is and what the specification is really trying to solve. And so we're going to take a look at reactive programming and a really quick refresher of what that is in a very high level view. Well, I am a visual person. So in order to, properly convey what reactive programming is, I a lot of times like to use simple examples that are pretty relatable, something that we're all fairly familiar with. So whether you're coming in from a, pretty hardcore data background or, maybe some more data engineering, application programming, it's likely that you've seen a scenario where you have a client communicating with a server, right? Whether it be a mobile application or a web application, something where the client is essentially sending a request or, a query of some sort to the server in order to get some information or perform some kind of operation. It's a pretty well-known or, pretty common scenario. But in this case, we're more specifically looking at how the client is going to make a request specifically to the server thread itself, right? So you can imagine it makes a request to maybe a server API. And on that server, it's going to use a thread to handle the processing and the operations that it needs to be doing. In this case, of course, specifically looking at a database because we're talking about a database specification. Makes sense. So in this scenario, the client sends the request and then the server thread is going to say, hey, this is we'll say a SQL query. I need to perform a structured query language statement on the underlying database. And it doesn't really matter what the database is, but it says, okay, I'm going to take this, I'm going to use whatever tools help me facilitate that and make a request to the database. But what's important for us to understand here is that while it's doing this, or essentially while it had sent this off, the server thread is just going to sit there and wait for a result. Now that result could take nanoseconds, milliseconds, it could take several seconds, depending on what the timeout may be. It could not return at all, but essentially it's going to wait for the database essentially to do its operations. And this is what's known as blocking IO, right? As it sits there waiting, it's blocked on the server thread side from doing anything else. But we know that, this is a problem that has been solved with more threads. So we can have the option if we've gotten our first request and we're essentially waiting for the database to return back the results, and we get another request from the client, we can simply spin up another server thread, or a third or fourth or 100 server threads, just depending on the processing and the capabilities of the underlying horsepower of the machine, essentially, or whatever we're happen to be running this on. But the problem with doing this isn't necessarily that, of course, now in 2021, we've got the capabilities to be able to handle things like what would be known as thread contact, or really the management of those threads. The issue is that if you're doing this, you're going to have some side effects. And one of those side effects is that it takes a lot more, or it could potentially take a lot more memory to be able to manage that thread context. And as you increase the memory usage, you may have things like drop off of throughput, where you may have decreased throughput capabilities from not only the database, but from the server itself. And so you're not necessarily using the underlying resources of the machine as efficiently as possible. And I stress efficiently because that's really the underlying foundation, or the underlying goal for reactive development, which is that if you're thinking reactively, you're thinking about efficiency. You're thinking of utilizing the underlying resources to the best of your abilities. And for another simple example, you can think of this as that same scenario where we've got the client then communicating with the server thread, right, in the background. And when the server thread communicates with the database or sends over those SQL statements or query or whatever it's doing, rather than wait for that query to return the results, the server thread is just essentially going to go on and do other, or manage or process other requests that come in. And eventually, when the database has finished its processing, finished doing whatever you've asked it to do, it can then tell the server thread, hey, I'm done. And this isn't some novel concept, right? This idea of thinking reactively, or reactive development, where you're essentially reacting to an event or to a message. It's in a broader scope. This is something that's existed, right? This is something that has existed throughout patterns like the observer pattern. You're probably familiar with things like publisher subscriber mechanisms. And this is essentially the same thing, where you're using events or event-driven development to be able to communicate this information. But our question really is more, how can this be done at this point, right? So that's a very high level view of what's happening and how we're thinking reactively. But really, we need to think about how this can actually be done. And to do that, we really need to take a step back and take a look at the definition of reactive programming. Is the simplest way to understand that. And by definition, it is a declarative programming paradigm. So for those of you who may not be familiar, you can think of two different paradigms kind of as antonyms of each other. You've got declarative, which is defined here, and you've got imperative. And you're most likely very familiar with an imperative programming paradigm, which is where you have complete control over the steps in a process. But declarative is really more interested in what's accomplished or what you're trying to get, rather than how you're doing it. And so for declarative paradigm, you're using this concept of data streams, which we'll get into, and being able to handle changes or propagation of changes. And so, well, what does a data stream really mean? And if we're thinking very directly to the point, of course we know, right? It's a stream of data where you can call this a publisher, you could call it a producer. Essentially, you've got something on this left-hand side that is sending data to something that's receiving it. In this case, we'll call it a subscriber. And you could certainly just send all of the information. The publisher could just send everything all at once, no matter, not caring about velocity or volume of data going through. But that doesn't necessarily mean that the subscriber, on this right-hand side, can actually handle that information at either the velocity or even the volume which that data is coming in. And so as the data comes in, you have this possibility or this risk that exists of creating a backlog. And so eventually the subscriber may be able to get to these pieces of data or operations or whatever really is defined in that backlog. But the problem now is that, okay, so we're using a data stream, we're thinking reactively. Well, not really at this point, because now instead of having a problem, waiting on, whatever this publisher, whatever we've communicated with send the data, now we've just pushed the problem onto the right-hand side here into the consumer, where we have to wait to be able to process, what's in the backlog. And so that doesn't necessarily make us more efficient. It just shifts the problem to a different side. So in order to really understand, this problem or diagnose this and then be able to come up with a solution, we really need to understand at a deeper level what the anatomy of a data stream is. It's a little bit more complex, just a little bit, than what we saw on the last slide, which was just from point A to point B, you send some stuff. Instead, of course, we can start looking at data stream, and we know right off the bat that it has to start, right? It has to be able to initiate the stream of which is going to send that information to the consumer. And of course, we can reasonably assume that at that point that it has some kind of completion, right? I suppose it could just endlessly be able to do that, but we'd never be able to process everything. So we can assume that there is some completion event of some sort that says, hey, this is done. We've sent everything that we need to. And this is done over the course of time, right? It could be a nanosecond, as I mentioned before. It could be seconds or minutes or hours that this stream lasts. And this is done over the course of time. And during that stream process, from start to finish, the whole point of it is to send information, right? Send these variables, or what we would know as elements of data, through the stream or as part of the stream to be able to process on the other side. And these variables, as they're being sent, really have two avenues that they can go, in this fork in the road, which is that they can either successfully be received and processed, or they can unsuccessfully, right? They may result in some kind of disruption or an error, an exception, where the information was not able to be sent. And so this is really the anatomy of a data stream. Start, finish, information can either be sent or it can't be sent. But if we have these pieces or these anatomical features available to us within a data stream, then we can get into this idea and something that helps us be able to solve this problem of blocking I/O by utilizing something called back pressure. And to take a look at back pressure, I think this diagram works pretty well, where if you're just taking a hose of water to the face and you want to get a drink, well, there's only so much that you can, velocity and volume wise, really take into your body. And if you get a fire hose, of course, there's a lot of inefficiency happening here where you're not able to consume that adequately. And so you can imagine that your hands here, if it were possible to really squeeze a fire hose, you can control the flow, controlling both the volume that's coming through and, of course, the velocity of which that's coming through at that point. Of course, velocity, I guess, coming to the same, but you get the gist, is that you're basically making it where it's manageable in order to take that water into your system. And this is this is certainly relatable back to our publisher subscriber, where we push over the control to the right-hand side here to the consumer or the subscriber to tell the publisher that I want a certain amount of elements or data items or a certain volume of information that I'm capable of handling. And then the publisher then in turn can be able to send this over, and so forth and so on. So this starts to create a new standard, or back in 2013, really a new standard or specification was created by a group of developers at Lightbend, Pivotal, and Netflix, as they started to get into this idea of reactive programming and the reactive paradigm of creating a specification or a standardization around how ultimately the subscriber and the publisher communicate with each other. And as you can see here, you have the ability to request, as I had mentioned. You can cancel this stream altogether. And this is really facilitated through an intermediary called a subscription. And then on the publisher side, you have the ability then to call in the subscriber to tell it when it may be receiving another data item. You can push an error, and then obviously the ability to push completion. But this diagram doesn't for a lot of us, probably do a lot of justice. What is a little bit more intuitive, which is kind of funny, you know, switching from a diagram, is maybe code. Now, I know some of you out there probably aren't Java developers or maybe even in the JVM ecosystem, but that doesn't really matter. And as we look at, you know, how this new specification works, you don't have to be a Java expert to be able to do that. We're going to describe some things that are simple enough for really anybody to understand. And whether you're in Java or not, there's this idea of an interface, which is really just defining a structure of what we want an implementation, a class, an object-oriented programming to look like. And so the Reactive Streams API is really just a collection of interfaces where we define things like the publisher, the subscriber, and then relationships between them using the subscription. And in here, you can kind of see a loose flow of how the communication works. And on the top right-hand side, you can think of implementations of the Reactive Streams specification or API as things like Alpaca Project, RX or ReactiveX libraries, and then Project Reactor or Reactor Core. These are actual, and these are just a couple of actual implementations of the Reactive Streams API. And it's become so popular that actually back in Java 9, it was added directly in the library, directly in the concurrency library for handling flowables. And those are all implementations of the Reactive Streams API. Take a look at time here. I want to make sure that we've got enough time to get into the demonstration too. But why is this important? Well, the reactive database interactions that we need, you know, they, of course, as we've taken a look, they need to be highly efficient in order to be able to, you know, be able to facilitate an application that's already using reactive programming. So as I showed in the previous screen, there's already libraries that use reactive streams. And so as we take a look at reactive interactions with specifically relational databases, they in turn need to, you know, have something in common with those reactive libraries. And so it just makes sense to use something as standard as reactive streams. But most importantly, what's key here is that in order to be a fully reactive application, it has to be reactive on both the solution side, so as you think of the API or the server side application, but all the way into the database. Because otherwise, if you've got, say, blocking IO at the database level or, you know, database connection level, then the whole application is essentially blocked and nothing is really truly reactive at that point. In order, it needs to be fundamentally non-blocking and it needs to utilize back pressure, which is why we're going to be talking about how R2DBC is really built on top of reactive streams. And this is all really in response to JDBC, or the Java Database Connectivity Specification, something that was invented back in 1997 before reactive development kind of got its name or its moniker and really became popular. Now, of course, as I'd mentioned, event-driven development wasn't necessarily novel even then, but it wasn't used to the scale that it is now, as certainly popularity and kind of have the, you know, reactive movement behind it. And when the when JDBC was first created, you know, I mean, it's meant to be a blocking driver. I mean, it's meant to block and you wait for, you know, the results to return. And of course, the reaction to that was that, okay, well, I can spin up asynchronously different, you know, different threads, different, you know, multiple pieces of concurrency, or I can handle it through concurrency in order to just be able to alleviate, you know, this fact that it's blocked, just utilizing more resources underneath. So, you know, sacrificing efficiency or true efficiency for speed and performance, you know, the ability to handle this asynchronously. Which brings us into R2DBC. So for R2DBC, we need to take a look at what it is. And by now, you've probably guessed, much like JDBC, that it is an acronym. And quite literally here, I've put it up on the screen, is the two R's are for reactive, relational, and then DB for database connectivity. And this is essentially just defining a specification, as we'll get into, for being able to communicate reactively with an underlying relational data storage mechanism. Doesn't necessarily have to be a relational database, but that's the most common use case. And some of the goals for R2DBC, of course, you know, rooted under everything is this ability to perform, you know, non-blocking IO, you know, executions and processes, right? To create a very efficient application or efficient workflow. But some of the other things that they wanted to accomplish were, being able to keep this as a completely open specification, right? They wanted to keep it lightweight and open, so that there was a lot of transparency in the development and there was community involvement, like there is in a lot of things that are open source. But of course, it needs to be completely non-blocking, and it needs to be done so all the way to the database, as the specification can indicate. And to do that, rather than reinvent the wheel of, having to implement, ways of handling things like back pressure in this non-blocking approach, the idea is to use reactive streams specification, or the types and patterns within that specification, in order to be able to build R2DBC on top of that, which we'll get into. And this is all in an effort, right, as a specification, to keep this as lightweight and minimalistic as possible, so that as a specification, which is really just the construct, or you can think of it as the requirements for an R2DBC implementation, vendors like MySQL or MariaDB or Postgres can come in and then build their own connector or their own driver, which we'll see on top of that. And from there, they can start to add more humane decisions, or what you can think of as adding in more opinions, one for the vendor themselves, but the way that they may do things. And then even beyond that, we'll take a look at client libraries that can be used to create even more opinions. Of course, all this we'll get into. But it really all starts with the ability to create a reactive solution, as we see here at the top, and then utilizing R2DBC, as I've kind of pounded the pulpit here, is, with the purpose of, with the little green check mark, to be completely non-blocking when we're communicating with the underlying database, whatever that is. But it utilizes this, as I've, previously kind of glossed over, in two ways. One, there is what's called the R2DBC SPI, which is the Service Provider Interface, which I'm going to dive into. And that Service Provider Interfaces defines a collection of interfaces, an abstract class, and even a couple of class implementations that then a reactive driver from a vendor like MySQL or MariaDB can go and create, which does all of the actual underlying, it does the implementation of reactive, the reactive approaches, and then using wire protocol to do all the communication with the database underneath. Now, the R2DB Service Provider Interface or known as the SPI, really, as I had mentioned before, really just defines two levels of code here, which is that is something that needs to be, as an interface, a collection of interfaces, needs to be fully supported. So as a vendor comes in and they start to crank away on the class implementations of these interfaces you see on the left-hand side, everything in there needs to be fully supported. On the right-hand side, there's a collection of things that need to be partially supported. Now, this isn't the entire list, but the gist of this is that there's things that need to be fully supported, of course, and then things that need to be partially supported. And the partially supported pieces in here are really to help facilitate vendor, humane design or opinionated design, where they can then adjust or add to their implementation of a driver in order to account for different database features. And so, of course, we know that relational databases at the core are largely the same as far as, how they are ACID compliant, they use transactions. There's certain things that, of course, that they use with relational design that's all very similar. But then, of course, as you get into different database vendors, there's going to be some differences there, which is what this is intending to support. Now, as we dive into the SPI, I really just want to show you for a couple of reasons. One, to show you how simple it is. And again, just to reiterate the fact that it is an interface. It's just defining the structure that an underlying implementation by MariaDB or Postgres or MySQL is actually going to create for the driver. But the other thing I want to point out, and the reason why I kind of harped on reactive streams, so talking about reactive streams before, is that the Reactive Streams API is really the foundation for R2DBC. It is what is being used from a publisher, subscriber, subscription perspective in order to facilitate reactive communication with this specification, the R2DBC specification. And as you can see here, there's an import, of course, bringing in the reactive streams, specifically in this case, a publisher. And as we take a look at the method declaration inside of Connection Factory. Now, a connection factory's job is to produce connections. Now, normally in like say a JDBC or really any other type of driver, whether it be Node.js or a .NET driver or something like that, the idea is that when you call create, it's going to return back to you a connection object. But in R2DBC, of course, it's going to give you a publisher. And then that publisher is something that you can subscribe to. And then when the publisher is ready, or when the object has been created that you've requested in this situation, then it's going to be sent to you reactively, right? This message-driven approach of, I'm going to receive this connection rather than I'm going to call this, wait for it to be spun up. I'm simply going to get a publisher. I'm going to subscribe to that publisher, as we'll see. And then at some point in the future, that connection is going to be given to me. And this is a common theme throughout the specification or throughout the SPI of R2DBC, where we have reactive streams using the reactive streams publisher, but for method declarations, for instance, inside of the connection interface, where we're defining how we would begin a transaction with the database, how we would commit a transaction, how we'd even close the connection. All of these are done using reactive approaches, right? So you're subscribing to a publisher and then it's done at some point in the future. And there's a lot of other methods that I'm kind of abstracting away, or I'm kind of obfuscating away here. But the intention here is to really show you how reactive streams is being utilized. And then as you start to drill down, you've had your connection factory, which produced a connection. We looked at connection with the whole idea that you're able to get this statement object of some sort derived from this statement interface so that you can execute a SQL statement. So being able to execute SQL exactly how you'd be able to do it inside of like a driver like JDBC or any other driver that handles SQL against a relational database. You can do that the same, but again, with the idea that you're getting a publisher back, and then you're subscribing to the idea that once it's executed, I want to receive the results, but you'll get those at some time in the future. Could be immediately, could be milliseconds, could be seconds. And we'll dive into what indicates or what dictates that here in a little bit. And of course, as you get results back, as you get, you execute your statement, then you may get a list of results or a single result back. And the theme really here is the same. And then as you get into the results, you have the ability to take a look. You can think of a result as a row inside of, it's a row that's coming back of data. And inside of that, then that row, which is inside the result, then you can take a look at specific indexes by name or by number and be able to pull out the value that's indicated, for that collection of tabular data or relational data. Things that you're probably already familiar with, but it's to show some similarities and how it's pretty much the same as how you'd expect to be able to communicate with a JDBC driver. You're just doing it in a reactive fashion. But how can you use it? So now we've taken a look at the reactive specification, or the R2DBC specification as a whole, but now we want to take a look at exactly how you can use it. Well, this all comes down to R2DBC drivers, as I've mentioned before, and they're the implementations of the specification themselves. And there's a variety of them out there. And by and large, a lot of what I'm going to show you in the next couple slides are the same. So whether you want to use Cloud Spanner's driver, MySQL, SQL Server Spanner, they're all going to be pretty much the same until you start to get, of course, into database specific features, which I'm not going to go into in this presentation anyways. Really, we just want to look at how you could be able to use one of these drivers. And having to work at MariaDB developer relations specifically, I'm going to go ahead and take a look at the MariaDB implementation. But again, a lot of these implementations specifically for what I'm going to be showing you are pretty much the same. And that's because if we take a look at the first thing that we need to do, which is defining configuration, right? You're just defining your connection credentials or your connection configuration, your settings to be able to communicate, connect to and then communicate to an underlying relational database. And for that, we've just preceded it with MariaDB. And so you can define this MariaDB connection configuration object. And it's defined this way because this is really just an implementation or an actual class implementation of the connection configuration interface. And so then you can define things like the host URL, the port number, username, password, and of course, anything else. Maybe you've got SSL types of credentials in there, certificates, any of those things, of course, you could be able to add into it. And then as you start to see a theme, this idea of MariaDB preceding things like connection factory, which we previously saw as an interface. Well, this is the implementation of that interface where we've got a MariaDB connection factory. We're using the connection configuration to instantiate a connection factory. And then below here, you can see that I'm using that con factory object .create, but then you can see that I'm using block. Well, that's because for a connection, for instance, yeah, you could wait for a connection to return at any given time, but you really can't do anything past a connection without having one. And so in these reactive libraries, whether it's Rx Java or it's Project Reactor, you have the ability to wait or block, which is essentially going to do just that. It allows you to wait and be able to establish that connection. You're not going to use that very often, but there are certain circumstances where you can, and it's great to have that control where you can switch between blocked and non-blocked processing. And that brings us to this massive, or not really massive, but kind of this like, this code on here that, especially if you're not familiar with Java, you're like, oh, wow, that's some color, some highlighting of the code, but that's a lot of code just in general. And this is really done intentionally. As we take a look at this, we're looking at being able to create a MariaDB statement from our connection object, and then we can define inside of there our select star from this task table. We can then use that select statement object to then be able to execute, and it gives us back a select publisher. Now, from that select publisher, of course, that's just an interface, right? As we see publisher and MariaDB result. Where Flux comes into this is Flux is an implementation of the publisher interface, which is from Reactive Streams, inside of Project Reactor. And, there's a variety of different, whether it be, flowable, there's a variety of different types of implementations for different libraries. None of that's really important. What's important for us is that whether it's R2DBC or Reactive Streams, we need to have an implementation or an actual class that's filled out to be able to use it. And then once you have this publisher, you can basically map some things in there. So on the publisher side, you can say, okay, as these results return, I want to map this into specifically a task object. And then at the very end of this, then you can subscribe. And that's the process that then you're going to wait for. Whenever the publisher is ready, it's going to, it's ready and it's able, it's going to send that to the subscriber. But this is a decent amount of code. And as you start to think about how you'd create a data layer, and persistence layer on top of this, you don't really probably want to reinvent the wheel, right? You're trying to think of all these pieces that may come into place. You got to create a connection factory. From there, you've got to have the configuration. How do you store that? How do you, then close down connections and having to deal with things like persistence of objects at that point. That's where, as I mentioned before, R2DBC and its minimalism become very handy, where the idea of the specification of R2DBC was to be small. Vendors, right, can actually create their implementations with drivers. But the whole intention of R2DB's minimalism is so that through that specification, things like clients or abstraction libraries that abstract away some of these things and more opinionated things as far as how to maintain data access, how to maintain things like persistence, are done through client libraries. And we're going to be taking a look at, I've got about 10 minutes here, but we're going to be taking a look at the Spring Data library, which is, if you're familiar with the Spring framework, it does a lot of abstraction. There's things that you can do with APIs and being able to, help you create solutions just in general. We're not going to get into any of that. What's important, what we want to get into is that one, it is Spring Data, whether you're familiar with it or not, is simply, it's our client library that we're going to be used to handle things like data access and persistence, but coupled with an existing R2DBC driver so that we can very quickly get in and see not only how to connect to a database, but then how to use things like non-blocking back pressure. So without further ado, I'm going to go ahead and jump into some code here. Now, I'm going to be using an integrated development environment called Visual Studio Code. But it doesn't really matter what you use. And for our purposes, we're not going to jump too much into the Java, what is called a Maven project. But we're just going to very quickly look at some of the pieces that you can add, really focusing on how easy it is to get started with R2DBC and Spring Data to be able to create a non-blocking application using a relational database. On the left-hand side here, I'm going to start by taking a look at my Solution Explorer. And this just organizes everything within my Java project. And I pre-created this Java project so we don't have to go through the minutia of kind of adding dependencies. But I do want to take a look at some of the dependencies because they're going to highlight some of the things that I've featured within this talk so far. First and foremost, we want to use the Spring Data R2DBC library. And Spring has its, it's got a kind of a reference tree or, a dependency chain that it has to take care of. And so I've just really generated this through start.spring.io, which is an initializer, right? It just creates the project or generates it for us. But this is our Spring Data R2DBC dependency, which again is that client library for R2DBC. And I'm going to be using the MariaDB R2DBC driver. This is how you set the dependency. It's pulling these from something called the Maven Central Repository. That's really all we need to know. I'm going to use something called Lombok, which is basically just a tool of laziness that I use so I don't have to set getters and setters, really just for one class, but it kind of shrinks the code a little bit. And then most importantly here, we are also using Project Reactor, which is a dependency within the MariaDB implementation of Vendor, which is, again, that Reactive Streams implementation library that then MariaDB uses to implement R2DBC. That's all we need to know. From there, we'll want to jump into a file called application properties. And application properties, I'm going to go ahead and paste in some code here just because we're running a little bit short on time and I want to make sure that we get through all this. I'm just going to paste in some of the requirements. And again, it's not really worth me typing because simply what I'm doing is that using some of these Spring presets, it allows me to do things like set the connection string. So something we didn't go over, but you can certainly dive into the documentation on R2DBC is that you have the ability to establish a connection string using R2DBC, just like you would use in JDBC, where you define R2DBC, you can define the vendor, the host address, and then the port number. And you can establish, if you want to, the database that we're going to be connecting to. I'm just going to be looking at a very simple database where we're going to look at a table called task. And then, of course, you can define a username and password. And if you wanted to add things like SSL, encryption, and a variety of other, features and functionality along with this, this is where you would do that in applications.property. From there, we really just want to jump directly into a main method. And we're going to be taking a look at just a single file. And of course, this isn't a production grade application. It's really just to show you how easy it is to, one, bring in the dependency, which is already in, establish communication with an existing database instance, in this case, MariaDB, and then be able to connect to it and communicate with it using R2DBC. Now, for this application, of course, it's a Spring Boot application, but we're not going to go through the process of creating like an API with endpoints. I really just want to look at an application running in the console so that we can show exactly how we can actually connect to and then be able to communicate with the database underneath. And for this, I've done some things here you may notice to keep the application running. And this is important because in order for us to get the full benefit, or at least visually get the benefit of R2DBC, we need to keep the application running. Otherwise, what's going to happen is it's going to start the application. Because we're using a reactive paradigm or reactive approach, it could end up finishing the execution of the actual terminal application before I'm done the processing. Of course, that wouldn't help at all. So this is just going to keep the application so we can see the printouts. Now, from here, and again, I'm just going to paste some things in here because I am running a little bit short on time. I'm going to take a look at the ability to maintain persistence. And to do that, I want to, to maintain persistence, of course, I'm going to do it outside of this class so I don't get weird indentions, but I want to be able to basically assign a task object or class to a task table. Now, for those of you that are familiar with things like ORM and this ability to be able to map things, this is probably very familiar. But we're using annotations here within Spring data R2DBC to be able to say, okay, I want this task object to be mapped to the task table that exists inside of MariaDB. And so if I take a look at terminal here, I can confirm, using, so I can say show databases. This is very simple. And I'm going to be targeting the to-do database. And then as I use to-do, I'm going to show tables. And I can see that I have just a single task table, which is a collection of tasks. And that's what I'm mapping this to. And of course, I can assign primary keys, such as ID. I can establish nullable credentials, all these things that you'd imagine that you could be able to do on the object side to map up to what is indicated inside of the table itself. So I'll save that. Now, that allows us then, of course, as we talk about being able to maintain persistence, so saving an object into something. But how do we actually connect to the database with R2DBC? And for that, you can very simply take a look at something I pasted in here again, an interface that I'm creating called Task Repository. And a repository just allows me to be able to execute events on, in this case, I'm pointing to a single table as my repository that's going to indicate things like the primary key is an integer, the fact that I'm going to be manipulating or using task objects, but I'm extending an interface that exists inside of the Spring Data R2DBC library, which is called Reactive CRUD repository. And this gives you all the basic create, read, update, and delete functionality, CRUD, that you would expect. And the combination of the Reactive CRUD repository with the connection settings that I put inside of application properties is what allows us to connect to MariaDB underneath the hood. So I'm going to go ahead, place that in there. So that allows us then to connect to it. So now we need to add functionality, which is allow us to actually call into that, which is where I can use something called auto wiring, which we don't necessarily need to get into. This is another topic called inversion of control, but just know that this is basically creating an instance of task repository for us that then we can call the CRUD operations that I mentioned before, being able to create a new task, select new task, update and delete new task. And from there, I'm going to go ahead and paste in a couple of methods to allow us to do that. Now we've got this implementation of task repository, I have the ability to then use the different CRUD methods that are available. So for instance, within the Reactive CRUD repository, I can use save, I can use find all, and I can be able to call those from my main method. So as before, I want to go ahead and I'm going to paste in a new task creation, and that task creation, then using application, which is why I've done some of these things here, basically creates an instance of this demo application. But I want to get in to be able to say, I want to use the save task method, which I added below here. And ultimately it's returning a mono, which is another implementation of our publisher. So mono just means that you're returning 0 to 1 objects, while flux, another publisher implementation, means 0 to many. So just a slightly different way, slightly different objects to return it. But of course, in save, we're not going to be receiving many objects. We're just going to receive the one confirmation, hopefully, that we saved. And then I can take that publisher of mono and subscribe to it to print out my results. So I'm going to go ahead and let's go ahead and run this. I'm going to just start debugging. And I'm going to run my application. And we can see here that I have created task ID 6, description task 5. I probably had previously had a task 5 in there, so now we have 2. And it's just returning to us what we saved. If I want to go ahead and look here, I can go ahead and show how in this same CRUD repository or the same repository, I can actually get task and then print out all the results using this CRUD repository. I can then just rerun the application after I've saved. And what this is going to do is it's actually going to then, of course, just show us all the information. So the subscriber is basically receiving these one element at a time, and then I'm able to print each result out as they come out, right? So I'm able to do this in a reactive fashion or an event-driven fashion. And I know we're a little bit over here, so if I need to be cut off, please let me know, but I have one last example. which is the ability to be able to use non-blocking back pressure to control the rate of flow or the velocity of flow from the publisher. Now, this is a pretty big paste in here, but what I want to show is that, like using application get task, which is what I was using before to subscribe to the elements coming through one at a time, I can actually create a custom subscriber. And this is important because the custom subscriber lets me step into what is the R2DBC, or more importantly, the Reactive Streams API, and be able to customize things like how many items I want to request from the publisher. So thinking back to the subscriber having control on back pressure, this is exactly what that is. So I can instantiate a subscription. I can be able to set how many on next I want, and then the amount of elements or amount of data items, in this case tasks, that I want to receive. On the subscription, so initially whenever I'm subscribing, the publisher is of course going to be able to call on subscribe with the subscription, and I'm going to be able to set up this link. Now, once I set up the link between the subscriber and the publisher, I'm going to have an initial request amount, which is just the 2. From there, the publisher is then going to be able to send the information, and certain things are going to be triggered, like an on next event. So when I receive each one of these elements, I'm going to increment the on next amount, and then I'm just simply saying for every 2, using modular division, for every 2 elements that are received, I want to go ahead and request 2 more. So if it takes 10 minutes to receive 2, then I'm not going to request again until I've received the second one. In this case, it'll be instant, but you can imagine that you could set all kinds of different settings in here. And then of course, if I happen to run into an error or whenever I complete, I'm going to log those things as well. So I'm going to go ahead and run this, and we can see in instant time that we'll get, of course, the event for being able to subscribe. I'm going to receive 2 elements, then I'll request 2 more and receive 2 more, and then request 2 more. Now, if you can see at the end of this is that I'm going to request 2 more, but at this point, I don't have anything else left. There's only 6 tasks that exist inside of my table, so I'm going to complete. And that's it. That is all there is to R2DBC and being able to use it within your applications. I can flip back over into the slides here very quickly. If you happen to have any more questions, of course, follow me. I'm going to jump into spatial chat right after this. I'll be there to answer questions. We can do some screen shares and take a look at some of the different parts of code. Feel free to go to r2dbc.io. The current release is 8.4. There is a new version or a new release coming out, 9, and it's intended to be GA or 1.0 by the end of 2021. I recently wrote the first book on R2DBC. It's available now on Amazon or through Apress or a variety of different vendors, called R2DBC Revealed. You can go ahead and get in touch with me at robh@meridian.com, on Twitter, or on my GitHub. Thank you very much, and I will see you in the spatial chat.